Hi students, so welcome to Physics to Learn AR channel. So in previous classes we have been discussed regarding gravitation. So as a part 1, part 2, part 3, part 4, part 5. If you have not been watched that, I am giving in description. Please you can watch it. So in this class we are going to discuss regarding the concept of effect of rotation of Earth on acceleration due to gravity. So in previous class we have been discussed how the G value can varies by using depth and height. So how G value can varies because of rotation of Earth, now which we are going to discuss. So that heading which we can take it as variation of G with latitude due to rotational motion of Earth. For this, so which I have been considered a point P on the Earth. Let phi equals to angle made by radius vector with horizontal line as a equator. So the forces acting on the body are here, the two forces will be there. So one we can take it as weight mg towards the center, and then centrifugal force, that centrifugal force which is nothing but m omega square into r. So we have been discussed while discussing circular motion, a body have to be moved in circular motion means it requires some force. That force is nothing but centrifugal or centripetal force. Here the force which I can take it as centrifugal force, which is equals to m omega square into r. So which can act weight always towards the center, and object which is a rotation. You can observe this, the dotted lines which represents rotation of that body which is at point P, because Earth is rotating about itself. So along with the Earth, object is also in rotation. That radius which I can take it as a small r, and here the one which I can take it as a centrifugal force, which is nothing but m omega square r. So with the help of mathematics, here if it is making certain angle phi, here also it will make the same angle as a phi. So mg is balanced by, so which one force? So for that, so this centrifugal force m omega square r, which we are going to resolve. So the component along the radius would be m r omega square cos pi, which I am going to get it. So this mg which has been balanced by m r omega square cos pi. This one how we have been obtained means because this m r omega square can split up into two components, horizontal component and vertical component. The component m r omega square cos pi will try to minimize the actual weight mg. So based on that which we can tell it, that which I can take it as mg dash. Let mg dash represents the apparent weight of the body. So with this diagram, if g dash is the value of effective acceleration due to gravity at point P, so which I have been taken, I can get it as, so mg dash which is equals to, so mg which is acting towards the center of the body minus, so m r omega square cos pi which is acting away from the Earth, that is nothing but centrifugal force. So by making this, so m as a common, g dash which is equals to g minus r omega square cos pi, which I am going to get. With the help of this, so g minus, here the value of r which we have been written in terms of radius of Earth, we can write it as, so that small r value which is equals to r cos pi. So based on resolution of vectors, so which we can write down, so into omega square cos pi. So by r, small r is equals to r cos pi, so which I can write cos pi is nothing but so adjacent side by hypotenuse. So with the help of that, which we can get it. So g dash is equals to g minus r omega square cos square pi. So with this, so which we can tell it as, so because of when earth is rotating, so g dash value which is going to be decrease. That means which depends upon the value with how much of angle it has been made with respect to horizontal. So at poles, so how it will be, at poles we have been taken, so which is nothing but, so gp is the value of effective acceleration due to gravity at poles. So if you have been seen here, so the angle so which you have been taken it as, so angle between these horizontal and then vertical we have been taken, it will be of 90 degrees. So gp is equals to g minus r omega square cos pi, which you are going to get. So this pi value is nothing but cos 90. So what's the value of cos 90? Cos 90 value is nothing but 0. So by substituting that, r 0 into anything will be 0. So that at the poles we have been taken gp value which is equals to g. That we have been proved small g, sorry capital G into capital M into r square, which we can get it. So this is nothing but which have been proved a relation between small g and capital G, which we have been proved this. So variation of g with latitude due to the rotational motion of the earth at equator. So what we can get it. So at an equator, so at point P, so what is the angle which we have been taken, that's value which is equals to 0 degrees. G suffix E, acceleration due to gravity at equator, is the value of effective acceleration due to gravity at the equator. So GE is equals to capital G minus r omega square cos square pi, which we can get it. We know cos 0 is nothing but 1, cos square 0 is nothing but, which you are going to get it as a 1. So with the help of that, pi is equals to 0, cos pi is equals to 1. So that GE is equals to G minus r omega square. That means at the equator, so which you have been taken, G value will be less. So latitude is defined as angle made by the line joining the given point on the earth to the center of the earth with the equatorial line is called latitude. So this in simple form we can call it as variation of g with latitude also, which we can tell it. So from the above equations we can conclude that the value of g at the poles is independent of rotation of the earth. So we can tell it as, due to rotation of earth, g is maximum at the poles and minimum at the equator. So which we can tell it. So with the help of this we can see MCQs. So as one move from north pole of the earth to south pole, the value of g along the path decreases and becomes minimum, increases and becomes maximum, first decreases and then increases to its initial value, first increases and then decreases. Please pause the video and write the answer in comment, like it and share to your friends. So answer is first decreases and then increases to its initial value. If the speed of rotation of Earth decreases, the value of G increases at the equator, decreases at the equator, increases at the poles, decreases at the poles. So answer is increases at the equator. Please subscribe my channel, like, share to your friends. Thank you. Have a nice day.